AM. And we have passed already 2 days, coming to know a lot of new things, which is beyond classroom. We would like to share with you. Yesterday you have been to site, and a lot of interesting things you have noted. Most important part is that the construction which was going on at a village area where no facilities were there, but the kind of interaction that we had with the construction worker, they are very sound, lots of experience are there. Engineer comes with drawing, but he could not show the drawing. But of course, we didn't go prepared that way. They also not prepared. More than 40 workers are working in the site. And whatever first-hand information that we have collected, we are all engineers over here. Whatever information we have collected through interaction with them, and whatever you have seen going up to the pier level, and the kind of arrangement that made at the site, concreting and everything, they are really got the attention of at least me, that what a great thing these people are doing out of nothing. Out of nothing, no facility, nothing is there. Such a mega construction of international standard, or following the load and everything they are constructing. But at the site, the kind of facilities that they are having, based on the experience, which are not documented, which are not countable, which will never see such kind of format or document. And these people, they work generations after generation, and we are having, most of us, we are having the formal degree from engineering college or institutes or IIT, but the sacrifice that these people have been motivated to work day and night with not much facilities that around, khana pina ka koi ठिकाना नहीं है, कुछ नहीं है, but the kind of skill workmanship that these people are doing, probably this for ages together, this goes unrecognized. I think if at all that you have known, which you will discuss after formal presentation by Dr. Prasad, who is from Civil Engineering Department, he will take you to some area, self-compacting concrete, which he has the specialization. I think it is a new way of concreting, even though more than almost 2.5 decade old technology started in Japan. But the kind of reinforcement, that is why I'm giving a little bit of introduction, the kind of things that we have noted there, reinforcement rods, they are having some space so close that normal concrete with RMC will not enter into that. And use of vibrator is an old concept. We still believe in vibrator, and at that site, without vibrator, it is not possible to have the concrete. At least from outside, you have seen with the shuttering and impression that you have seen the finishing, and using vibrator, they have made it to the standard. Probably we will not be able to evaluate their performance at the site, even maybe another 1 decade later. By the time the kind of technology that has come, the self-compacting concrete, which Dr. Prasad is going to tell you, that what you have observed there, that the stone chips and things will not enter without using vibrator, and vibrator creates lots of difficulty and segregations, which we know very well. And that is why people felt more than 25 years ago, especially in Japan, that why not develop high flow ability concrete which do not need vibrator, because when you use vibrator they will segregate. Once they segregate, the kind of quality or M20, M30, M40, whatever it is, you will not achieve that kind of strength. So self-compacting concrete is one such. I think telling something about that doesn't suit my way. I'm not a specialist there. I would request that Dr. Prasad will tell you about that. Thanks.
Thank you, sir. Good morning. Good morning.
This is the first formal lecture. Why don't we welcome him with clapping? No?
Thank you. Sir, thank you for giving it space and giving time to me to share my knowledge related to self-compacting concrete. I am Dr. L.V.PRASAD. From the last 5 to 6 years, I am working on this self-compacting concrete, and my research area is also this one. I completed my PhD from NIT Warangal. There, I developed the self-compacting concrete. That means for different grades, I have developed the mixed design procedure for self-compacting concrete. And not only the mixed design, even I have developed the stress strain curves for the self-compacting concrete. Because when you are developing a new concrete, you have to know its behavior also. How we know the behavior? If you know its behavior in compression, if I know its behavior in flexure. So if you want to know the behavior in compression and flexure, we know load distribution, load deformation curves, then stress strain curves, then moment curvature relationships. So that all I have developed in my research. So before going to introduce the self-compacting concrete, I have to introduce this Hajime Okamura. He is the father of the self-compacting concrete. In 1986, he has developed this new technology. Because what happens if I am using a regular concrete? One more thing I want to share. Before coming to this post, I am also a assistant executive engineer in public works department. So I know all of you know better what are the practical problems we are going to face. They will give some provisions as per the booklet or as per the provisions, whatever they have given, but it is very difficult to implement all of them. They will say this slump is required, they will say this is the concrete, and even practically we have seen yesterday what type of aggregate is available in the site. So it is very difficult to maintain the whatever the specifications you have, but you have to take a decision with the available material. You have to try to get the good quality of the concrete. So this is your own decision. Suppose if the aggregate is not that much quality, then whether you have to reduce its content, or you have to do what are the measures you have to take, so that even though if some material is not good, then also you are going to get a good concrete. So that practically, I think all of you are doing the same with your experience. So here what happens when we are working with the concrete in regular, generally, even if it is giving a strength, we are not expecting, we are not going to accept it without workability. Workability is the main criteria for the concrete. Strength through workability. That is the concept of concrete in the for the regular concrete. Suppose if you are going for high strength concrete, the concept is also similar to this. We are going to get the same strength through workability. Suppose if I am saying I am developing a M80 concrete or M60 concrete, I have to get the 80 MPa without compromising anywhere this workability properties. Workability means how easy you are going to work with that concrete. It should flow easily all the spaces. And yesterday we have seen that bridge. It is completely fully packed with the reinforcement, heavily reinforced. So in that cases, it is very difficult to compact the concrete. So because of that, he is developed a concrete in such a way that it is going to compact under its own weight. No need of any external vibration. And another thing, see, when we have seen the site, there you are getting any mechanized techniques. It is very difficult. Even they are bending the 32 mm rod also by manually. So in that places, getting a vibrator is also difficult. So that's why you have to develop a concrete. No need of using any external mechanism. No need of any external vibrators. Here in the mixed design itself, we are going to prepare a mechanism. So here the main concept is it should compact under its own weight. The thing is, suppose if you are taking a certain volume, in that you are putting all these ingredients. In our regular concrete, what happens generally, if you see the ratios, coarse aggregate content is more than the fine aggregate, and similarly fine aggregate content is more than the cement. Like that you are preparing, and if there are any voids, you are trying to compact and you want to avoid that voids by compaction. You are trying to minimize the voids. So here in this method, what we are going to do is, at the time of mixed design only, main concept is if it is densely packed, automatically the voids are going to be eliminated. If it is densely packed, directly you will get the, because if it is high density, automatically you will get the high strength. Strength is directly related with the density. In a given certain volume, if you are able to fill all the voids with the fines, no need of any external vibration. We are vibrating because to avoid these voids. So here in the mixed design itself, we are trying to eliminate the voids. For that content, here in SCC, actually what we are doing is, this is the generally coarse aggregate content is much in our regular concrete, and similarly sand proportion, then cement and water. So in the SCC, what we are going to do is, because if I am increasing the coarse aggregate content, automatically the voids are also increasing. So that's why I am going to limitize the coarse aggregate content. I am going to decrease the volume of the coarse content, but I am not going to reduce. I am not compromising the strength. Whatever the minimum coarse aggregate is required for that grade of concrete, that I am fixing. Then, because here I am trying to fill the voids with the fine powder, so that's why here sand content is more than the coarse aggregate content. Because the concept in the preparation of concrete is, whatever the voids formed by the coarse aggregate, they are filled with the sand, and whatever the voids are there in the sand, that are filled by the powder. So here fine materials, just like fine aggregate and powder. Here I am saying powder, not a cement, because let us say if it is a suppose I want to develop a M30 grade concrete. Generally, with the 350 kgs of cement, I can develop a 30 MPa. So directly, if I am using 350 kgs, it is not economical. Here we are thinking in the direction of economy, and we are thinking in the direction of sustainability also. Because what happens if I am using the more cement, more production of cement, then CO2 content is coming, then environmental problems, all that we are seeing. So in this method, what he is given a alternative is, here powder content is required more, but it is not with respect to cement. Whatever the minimum cement required for the hydration process. See, whatever the strength we are getting because of this hydration process of the cement. When you are curing, it is going under certain hydration process for a 28 days. Regularly, if you are curing the concrete for a 28 days, then it is going to achieve its target strength. So for the minimum, to achieve the target strength, minimum cement content is required. So whatever the minimum content of cement is required, that we are going to keep here, and the remaining content we are going to add as fly ash or GGBS, any mineral admixture we are going to add. The advantage of adding mineral admixture is, it is not only decreasing the cement content, and it is going to form a CSH gel. So that is, whatever the CO2 is there in the hydration process, in that it is going to react with the carbon. From the carbon dioxide, it is taking the carbon and it is forming a CHS gel. With the formation of CHS gel, what happens is, the durability of the concrete is going to be increased. So the self-compacting concrete is not only a high-strength concrete, it is going to give you a high-performance concrete. What is the difference between high-strength and high-performance? Durability of the structure is going to be increased. In high-strength, our concept is strength through workability. But in high-performance, strength through durability. Not only the strength, but how long it is going to give its strength. I don't want it for 1 year it is going to give its performance good. After that, you are going to face the durability problems. It is not like that. So it is going to give you a concrete which is high strength and high performance because of utilizing these waste materials, whatever the fly ash, silk, UGGBS, metacoilin, like that. We have different mineral admixtures. And another problem of disposal problem is also there from the fly ash and all these things. We are giving two types of solution. One is we are giving disposal problem. Another one, we are going to give a concrete at low cost with a high performance, that is with a high durability. So here the main concept is we are going to reduce the water powder ratio, because when I am saying automatically powder content is increasing, water is going to be reduced. But how you are going to achieve by reducing a water content, and you are saying it is a self-compacting, means it should flow under its own weight. For that purpose, we are using some super-plasticizers, high-range water-reducing admixtures. If I am adding a high-range water-reducing admixture, what happens is, even its quantity is less, but it is going to show its effect more in the workability properties and in the strength gain properties. Like that, we are going to add a super-plasticizer and viscosity modifying agent, because of this viscosity only, there is a chance of segregation, there is a chance of bleeding and all this. So if you are able to avoid this viscosity problems, then it can flow easily. So for that purpose, in the SCC, mainly we are using, the main is we are going to reduce the coarse aggregate content. Another thing is we are going to increase the powder. When I am saying increasing the powder, automatically water powder ratio reduces. So to compromise that, I am going to use the super-plasticizers and VMA. So these are the some threats to the future, because nowadays, even if you see, so much skilled labor is required. If you see the earlier site, we are working at a height of 20 feet. At that height, you have to pour the concrete. Definitely, you have to use the new technology. Otherwise, you are not going to get whatever the strength you are.
What about the water cement ratio? Do you compromise on that, seeing the water powder ratio?
That is, here we are not going to say water cement, we are going to say water powder. Cement plus fly ash. For that, we are going to add the water. That water, whatever required for a hydration process, that we are going to keep. But the remaining, generally, water is added just, if you see in the practicality, if you are not getting the workability, simply you are adding 1 mug extra. No rules, no regulations. Simply you will add 1 mug extra. But by adding 1 mug extra, you are going to lose your 1 MPa grade of concrete. So instead of that, we are going to add this high range water reducing admixtures. They are going to react in such a way that even if you are adding 5 liters of water, it is going to compromise with 1 liter of water. 1 liter of the super-plasticer, it is going to affect like a 5 liter water. So like that, we are going to use the super-plasticizers. We are going to use the new technology to get a high strength and high performance concrete.
So, PCC cement already 5 years is added.
Yes, but in practicality,
So what you are telling, there is cement, what type of cement? Whether it is OPC or PVC?
Yes, I am explaining that. When I am doing the experimentation in the lab, definitely I have to take the OPC and I have to decide what is the optimum dosage of fly ash. But in regular practice, if you see nowadays, everywhere you are getting the PCC only. PPC. In the PPC, if you see the cement bag, they will mention what is the generally accepted percentage is 20%. If you see any bag, PPC bag, they will mention 20 to 25% fly ash is added. That is sufficient. If you are going up to M40 grade of concrete, that is sufficient. In some cases, suppose if I want to prepare a high volume fly ash concrete, if I am crossing this 20 to 25 limit, even IS code says if you are adding 20 to 25, it is okay. But if I want to cross the limit, then the mixed design you have to try practically, then you can suggest. Now we are going up to 40% replacement of cement also. Even high standard, even if you take international standard stadiums also, they are also preparing it by using the fly ash, and they are replaced 40% of fly ash. One example I will say, in Hyderabad, Gachibowli, they have prepared a international stadium, but in that also they have replaced 40% of fly ash. Cement is replaced with 40%. Accordingly, you have to prepare the mixed design. Then only you have to use it.
And what types of fires you are using, sir?
In India, we are getting two types: Class C and Class F. But locally, almost we are.
In the cement company, they are using the fires generated from their company itself.
Yes. Here I am using Class C fly ash. Actually, when I am working in Warangal, it is a waste product from the industry.
Yes.
So some from steel plants or from cement factories you are getting. Actually, when I am using from the Andhra cements. The Andhra cements, there is a fly ash with them. So they are providing, even if you provide only the transportation charges, they are ready to give the fly ash, because it is a dumping problem for them. So, and here when I am saying it fly ash means it is a ash. There is a small correction in the collection process. If I am in the collection itself, if I am using any techniques, then I call it as a ground granulated blast furnace slab. It is also a slab, but how you are collecting, based on that we are given different namings. Fly ash is it just from directly collecting from the funnel, and we are using this. Mainly what happens in the ashes is they are very fine. So because of this fineness, they are going to spread more area, and they are occupying more area, and automatically they are going to fill the voids. Even when I am saying in our regular concrete, we are not thinking about the whatever the voids forming with respect to sand. But in SCC, because we are using these fine, very fine powders, so they are going to fill the, even whatever the with respect to sand also some voids are forming, that are also filled with the this mineral admixtures. Right. So when nowadays almost PPC we are using. So in that already fly ash content is there, 20 to 25%, and you have to develop a mixed design procedure with respect to that cement. Because when I am using a separate mix, see, I already have developed a SCC mix in the NIT Warangal, but I cannot say the same mix is suitable here, because here the sand is zone 4 sand. Whatever the sand I have used in the Warangal is, it is zone 2 sand. Accordingly, now I am guiding a research scholar, Prasenjit Shah. He is developing a SCC suitable to this northeast zone. We are not going to say use the same SCC proportions what I have developed in Warangal, because here the sand is zone 4 sand, and we know that in that so much of mud content, fines are more, and you are not going to get the same strength and all this. So we are trying to eliminate the problem of, see, and even collecting the sand is also very difficult. That's why we are going to replace the sand also. We are trying to give a solution to this zone 4 sand, adding some quarry rock dust, because in that
we are also using this.
you are also using
When mixed design, we are using crusher dust
crusher dust.
to improve the gradation of the sand from zone 1
Yes.
to zone 2.
Okay, okay, good, very nice. And we are also trying for SCC, not for a regular concrete, because here his work is, we decided the work is like that. He is going to develop the SCC, not only the SCC, that SCC should be suitable to this northeast zone, because mainly we are concentrating on sand. We are not replacing the both at a similar time, because if I am replacing aggregate and sand, then it is very difficult to say what is the effect. So that's why first we are trying to replace the sand, and how much optimum dosage I can replace. I cannot say completely 100% I cannot replace. So what is the optimum dosage of replacement of this zone 4 sand, so that it is going to improve its quality, and it is going to develop the self-compacting concrete. I will show some videos. What are the tests we are going. See, these are the practical problems. Yesterday also we have seen the piers. They are thickly and heavily reinforced. In that cases, even it is not possible to vibrate. If there is any chance of vibration possibility, then you can vibrate, but there is no chance of vibrating. So in that cases, SCC is going to work better. I will show some tests on SCC. These are all the related theories. Just I will show you. These are the actually for SCC, FNARC is given some specifications. When you are going to say SCC, self-compacting concrete. So for that, mainly we are using 4 tests. One is horizontal flow test. We are not going to take the slump, vertical slump, because it is high workable. High workable means we are not having a limit of 100 mm slump, not like vertical. We are going to see in the horizontal direction. Suppose if I am using the same slump cone, same slump cone is used here. If I am lifting that slump cone, it should flow horizontally minimum 600 mm. Then I am going to say it is because I am checking its passing flowability. That means just lifting the cone by its own weight, if it is able to spread 600 mm width, then I can say one test is it is possible, that is flowability. Similarly, we are going to have another test is called jarring test. So jarring means here I am going to keep the ring. In that I am going to use this cone and I am going to lift this cone. After lifting this, inside the ring, outside the ring, the height difference should not be less than, it should not cross 10 mm difference. If I am measuring inside the ring, outside the ring, the height difference, because if there is a height difference means it is not flown properly. Even why I am keeping this jarring means because in practicality you are going to have some obstruction. That obstruction is the reinforcement. So I am going to keep the same similar obstruction and I am trying, even if I am putting some obstruction, how it is going to flow. Even these videos I can show you. See how it is going to flow. It is a horizontal flow, not the vertical flow. So that dia, if I am taking, it should take minimum 600. The code says it should flow minimum 600 to 800 mm. Like that, we have to design. Similarly, we have a jarring test. So in this jarring test, suppose if I am lifting the cone, it is also going to flow, but inside the cone and outside the cone, if I am measuring the vertical heights, the height difference should not be 10 mm. That means that even if some obstruction is coming also, it is ready to flow. That is called passing ability. One is flowability, another one is passing ability. Similarly, we have segregation resistance test. That means segregation means if I am keeping the concrete for 5 minutes, 10 minutes, just like that, if it segregates generally. If I am keeping the concrete just in a container for 5 minutes, generally it is going to segregate. But here we are going to test even if I am keeping it 5 minutes just like that only, it should not segregate. For that we are going to use this V funnel. In this V funnel, first what we are going to do is I am totally filling this V funnel and there is a opening arrangement. If I am opening this V funnel, it should empty the V funnel within 6 to 12 seconds. If the concrete is able to empty the total volume of this V funnel within 6 to 12 seconds, then we can say it is a self-compacting concrete. It is not going to, that is one passing ability. Another test is, once again I am going to fill this V funnel and I am keeping for 5 minutes in that. Then I am going to open this. If then I am giving it chance to flow, at that time, the time difference, let us say initially it is taken some 8 seconds to complete the V funnel. Next time, after waiting 5 minutes, it should not cross plus 3 minutes extra. That means initially it is taken 8 seconds, it should not take 8 plus 3. That is 11 seconds. Within the 11 seconds, it should finish. Suppose after waiting 5 minutes also, it is finished emptying the thing within 11 seconds, then I can say no segregation. So like that, if it is satisfying all these tests, then only we are going to give a brand as self-compacting concrete. Nowadays, we are having flowable concretes. See, in the site, I asked them, they are using the flowing concrete. There is a small difference between the flowing concrete and self-compacting concrete. we are adding some retarders, so that they are going to keep some 45 minutes or 30 minutes based on your site place to execution site to the where you are preparing this concrete. Accordingly, we are going to add the these chemicals. So if you are adding that chemicals, they are going to keep until 45 minutes. It is still in the flowing stage only, and they are using these pipes, and they are going to keep the concrete. But there the compaction is required. It is only a flowable concrete, not a self-compacting concrete. Okay, so in this is also one type of U-box test. Similar to that, we are going to keep one side concrete and another side. Here we are having two sides. So first I will fill the concrete, then I will open this one, then it is going to through. That means if it is flowing from one side to another side, because it is, concrete is passing through the pipe. Even if it is passing through the pipe, even some vertical directions are there, then also it should pass. Like that also we are testing. That height difference should not be greater than 30 mm in that case. Then we are going to say it is the SCC. So for the mixed design, these are the FNARC specifications. European Federation is given some specifications. They says that if it is a slump cone, minimum maximum, it should be within these limits, 650 to 800 mm. That's slump cone. Similarly, T50 centimeters seconds. When I am saying horizontal flow, because all these are related to the shear, viscosity and shear. When I am saying with respect to concrete, this slump flow and all this we are saying with respect to that. Even if we are measuring with respect to time also, to flow that 500 mm diameter, it should take 2 to 5 seconds. It should not take more than the 5 seconds. Like that, by using these mixed proportions, we are going to say these are the some mixed proportions I have developed for M20, M25. Even I can use the ACI method or IS code method. Initially, I can start with that, but you have to go for trials. Actually, we are following a NANSU method of mixed design. If you are following Indian code, these are the proportions you are getting. But to get these proportions, you have to go for so many trials. And that too, see, I am saying this is if I am developed this in NIT Warangal, it is not suitable in NIT Silchar, because here again I have to go for the trials based on the material availability. Another thing, just 2 minutes I want to spare. Another thing is not only the self-compacting concrete, because nowadays we are seeing the curing also. Curing also a big problem. Actually, if it is cured for 28 days, then only it is even whatever the material you are using, whatever the quality of cement you are using. But in all government practices, I think no one is going for 28 days curing. Simply they will go for minimum of 7 days or 14 days maximum. So this is also a practical problem. So that's why now we are also working on self-curing concrete. Similar to this, we are going to add some epoxy coatings or polyethylene glycol, that is the chemical. So with that, whatever the chemicals they are having this polyethylene glycol, we are going to add this. Then no need of any curing. Even the practical tests we are doing here. Suppose if I am preparing one concrete with curing, another one is just like our practicals. I am preparing and I am leaving it. Another one is I am using this polyethylene glycol chemical. Then I am also not curing it. It is self-curing, no curing, and curing with water. Like that we are doing, and we are getting the good results. Even with the polyethylene glycol, even it is practically is also available. This L&T company is using this self-curing concrete in practice. Even the Lanco is using this self-compacting concrete. Practically in Bombay, in one tunnel, they have used self-compacting concrete, and even now in IIT Hyderabad, the new campus is preparing with the self-compacting concrete. It is slowly coming into the practicality. So, thank you very much for giving for an opportunity to share my ideas. Thank you. Any queries? Even in the break time also, if anyone want to discuss, I am ready to share my ideas. Thank you. Because sir will continue.
कोई क्वेरीज आपने देखा सेल्फ यहाँ पे कहीं कंस्ट्रक्शन होते हुए? Have you seen? Okay. It is going on now. Many special structures are coming up. Even in Delhi, it's coming up. There are admixtures. I was just asking our cameraman that what is the type of cement available in this locality and what is the cement brand and how they get marketing done, which is beyond Amazon.in or Flipkart kind of advertisement. So it's very interesting. Kind of uh, quality of cement that is available here locally. 2 weeks back when we are in Imphal, cement max, I think max, MAX, is एक बोरा cement का दाम है वहाँ पे. He says that now it is 450, but another 20 has added, 470 per bag. Here it is 300 or something, 350. Delhi also around, I think 275, 300, something like that. But Ambuja, they are capturing the market. Ambuja, Ultratech, this 3-4 company, but they have got tie-up with two global. One is Holcim, another is L.V.PRASAD. These are the globally they are controlling the market. Now all those cement companies that in India, Ambuja or Ultra and all they have been purchased by these people. Now there are two only. The entire market and production, manufacturing is all taken care of by these people. So as far as cement manufacturing, adding fly ash and other things are concerned, though it is a waste, but even IS code has come, as Dr. Prasad was telling, that even in other country, 40% admixture as a fly ash, they are replacing it. So it is a great thing that we have identified the right use of this product material, this waste material, which is not which is really in 1990s it was a headache, but these days we are using it in the cement. But even then, the kind of amount of fly ash that we are producing in the country, and it is becoming so much headache. Cement industry people, despite they are hardly using 0.001% of the total. Because how much cement you can use in the amount of fly ash that we are producing? If you see the statistics, that hardly minuscule amount that we are using there in the cement, but at least some good quality, durable things that we are finding. Now, these days, more than 90% of the uses are with this PPC. OPC has reduced. But anyway, that thing is for your knowledge sake that whatever cement quality is available and whatever steel that is available here locally and the kind of market being created, it all creates a lot of difference. When we talk to earthquake resistant measures, where in earthquake resistant measures, and yesterday we have shown you some video, day before yesterday we have discussed, and what is important is that the performance of the building, like you are showing some drawing, which are available since working stress method or limit state method, though it is there for the last 30 years. All those design and drawing has not changed much because we have to take some factor of safety, taking into account of the quality compromise that we have to have, because in market things are not available. So the drawing and design has not changed, and they are all textual book also glorifies such kind of design, and also in the courses in the high level MTech or PhD courses like SCC is unheard of here. But you have seen that 1986 it was discovered, or it is in the market, and all quality constructions are going on using SCC. And we started now using, and some research are going on, but still, because the sources of our natural material like building materials are so much uncertainty is there that we cannot use them properly, and that is why we cannot give performance guarantee to our kids. But you look at some other branches of our engineering, like aerospace or that aircraft. We come every day. Accident rates are very few. Don't you think that they give performance guarantee? Aeroplane, if there is a little bit of imbalance and other things, what will happen? Accident rate is hardly few. So if you think of, compare that of our guarantee or warranty of civil engineering structure where civil engineers are involved, from the design, concept, land use planning, constructions, quality monitoring, and now we are taking about finding out the disease in the building through a rapid visual screening, and then identify the disease and then think of retrofitting. And in retrofitting, then we'll talk to you some of those techniques like base isolation or dampers, and then jacketing, FRP plastics. Many new branches of such kind of treatments have come up, which in this course we cannot tell you much of the details, but we'll give you a glimpse of that. But the kind of performance guarantee that aerospace engineers or aerospace industry giving isn't it really a fantastic way of taking our basics of science to the applied science with so much that when a flight runs at a speed of 1,000 kilometers, nothing happens to that, very few accident happens. Don't you think that even the car that we are driving, so whatever they are designing, taking into field condition, taking into the kind of engine that they're developing, they are giving the performance guarantee. So same is the way that civil engineering industry has to come forward to take these things in the priority. So now I think we shall start with some aspects before we start discussion, because today you have promised, or rather we have told you that we have made 5 groups, and each group will present your experience. We were there, but you will share your experience, especially the breeze side. And then when we came to the police station, you try to fill up the format given to you. So whoever is the group leader, 5 of you, each one of you will be given 10 to 15 minutes time. And then you will share and we will be sitting here like that. But before that thing starts, I don't know how many of you are ready for the presentation or discussions, whatever way. You can put your pen drive here, show some photograph and what observations you have made. Some of the things we have discussed there at the site itself before leaving the breeze site.
Yeah. Sharing our knowledge.
Rather, I would not say you are most welcome to be here, because that part is over, because we have forced you that you have to be here. 5 group presentations from your side, where you will show some of the photographs, and then we will be here. Dr. Raman is here, and Dr. Prasad is there, and we too, and then other few people will be sitting here. We will be examining your presentation skill, the center observation skill.
He's just joking. It's not the examination. and don't worry, it's not the examination and no marking, nothing. It's just the sharing of experiences.
Yeah. Sharing of it.
Just what we have learned together. It's just what we learned yesterday, and how can we improve all those things. This is just the experience sharing.
And also, what are the difficulties they are facing?
Exactly. They are facing, we are facing, in light of all those things, all based on your experiences, based on these 3 days interaction.
Yeah.
How can we improve all those things?
How can we improve ourselves?
Exactly.
Because we have been giving you, like SCC is, you have not heard, and maybe after 10 years it will come. With our MTech students now, not even 50% are present here. So please call them whatever way that they should come here. Before that, your discussion over, we are giving you still some more time. I will call Professor Raman here to share his.
And before we request Raman Saab to make a presentation, we have to break for a tea.
Oh,
tea break. So
You are not.
yeah. So let's go for a quick tea break and then come in as soon as possible.
Okay.
Okay.
मोबाइल ऐप्स यूज करते थे
कंपाइल में ऐसे ही होता है कोई अपना किसी का प्रेजेंटेशन केवल from this side was but it was good.
Please. Because আমরা যে চা খেয়ে নিচ্ছি
সকালে উঠে দেখেছি কোনো মেসেজ আছে হ্যাঁ কোনো মেসেজ আমার মেইলে গিয়ে নেই আমার মেসেজ share your experience with Morgan.
So
আমি দেখিনি কিছু আমি দেখে নেই স্যার চা খাই স্যার আমি একটা এক কাপ চা খাবো দেখে নেই
এখানে চা
इसमें लोग सर आपका लैपटॉप यूज करेगा ये वोकल के आप करेगा
सुनो
सुनो ये किधर आओ ना हेलो कोई एक आओ साथ का कनेक्ट करना है एनीवन इसको
NITM আরেকটা হচ্ছে স্টেটে একটা সিস্টেম ওটা
আমরা গেছিলাম ওখানে আগস্ট नहीं ये प्रेजेंटेशन कंप्लीट होने के बाद तो एक काम करते क्योंकि लास्ट टाइम जो सब कंप्लीट हो गया
आगे একটা শুরু হয়েছে Yes, sir. এটা আবার দিকে আমাদের
লেকচারের জন্য পূর্বে এরা জানে না
Hey sir, I am Amit. I work with him at NITM. Have a seat, please. Backing up.
I know him through IGC and
He is so popular.
Very popular.
Not IGC, he is something in
Bigger than IGC.
Geological Society as well.
कहाँ पे पिक्चर
उसमें तो ज्यादा पॉपुलर
Exactly. So इनका ससुराल का एक ब्रांच तो हल्लाकांडी में भी है, हल्लाकांडी में है, पूरा नॉर्थ ईस्ट घिरा हुआ है इन्होंने, शिलोंग, इसीलिए हम जो है नॉर्थ ईस्ट में बहुत प्रोग्राम करते हैं, इसीलिए और इनके साथ और इन्हीं के साथ मैं भी आता हूँ क्योंकि ससुराल में बहुत अच्छा खाना मिलता है।
सेंटर में बना दीजिए तभी तक,
बना देंगे बना देंगे
कोऑर्डिनेटर ठीक है,
बना देंगे वॉलंटियर्स की कमी नहीं है। आइए सर चाय पीते हैं, चाय के लिए आइए सर।
सर वो लोग रखेगा सर, आप इधर वक्त दे मैं बोल
देखना पड़ेगा।
अच्छा
इधर है कि आपके लिए पीपीटी की जरूरत नहीं सर, नहीं पीपीटी की जरूरत है ना, आपके लिए जरूरत है। हाँ
rail voltage.
जस्ट आपका ही प्रेजेंटेशन ডিরেকশন কভার করে রেখেছে ডিরেকশন এত বেশি হ্যালো
বুঝছ না
এই যে
ইনফরমেশন
ডাইরেক্ট